very good morning, good afternoon, good night, whenever you will watch this video. So today we are meeting over here to calculate the best numericals as well as very much important numericals which are present in the chapter of properties of steam. Now in this video, whatever equations and whatever methods that I am going to teach you, these methods and equations, if you are able to understand properly, then you can solve almost every type of the numericals based on properties of steam. So let us start with this video without wasting any time. I hope you are ready with your pen and paper. So before taking a numerical, first of all we will write some equations which are important to calculate the numericals based on properties of steam. Now first of all, that you know very well that total three types of the steams are there. First steam is known as saturated steam. So I will write saturated steam. It is also known as dry and saturated also. So two names are there for saturated steam as well as dry and saturated. Then next steam is your wet steam. So over here I will write wet steam. Then next steam is your superheated steam. Now numericals are based on that three steams only. After that, in all that steams, which are the equations for different parameters that we will discuss. Supposing first of all I will say x means dryness fraction. So for dry and saturated steam, dryness fraction is always 1. For wet steam, dryness fraction is lying in between 0 and 1. And for superheated steam, dryness fraction is not applicable, or for superheated steam, dryness fraction is not present. After that, if I will take next parameter, so it will be your enthalpy H. For dry and saturated steam or saturated steam, enthalpy is always Hg, enthalpy of gas. For wet steam, it is HF plus HFG. And for superheated steam, it is your Hg plus a CPS. T superheated minus a T saturated. Now next we will go with last one, which is your specific volume V. So specific volume for saturated steam or dry saturated steam is Vg. For wet steam it is X into Vg, and for that superheated steam it will be your V saturated by T saturated into T superheated. That is the equation. So that table you have to remember. According to that table, numericals we will calculate. Now after that, over here I will write, after that, if you want to find out the internal energy, so internal energy is denoted by U. U is equals to H minus PV, in which H is in kilojoule per kg, pressure must be in bar, and volume must be in meter cube per kg. Now over here, that is your kilojoule per kg and that is your bar into meter cube per kg. So that term, if you want to convert in kilojoule per kg, at that time this term will multiply with 10 raised to 2. Then only that answer will be in kilojoule per kg. So in this equation, that P into V, that you have to multiply with 10 raised to 2 for each and every numericals. But condition is what? Pressure must be in bar and volume must be in meter cube per kg. Then this equation PV is multiplied with 10 raised to 2. Then only you will get the answer of internal energy in kilojoule per kg. Now that much equations are useful, but at the end of this video we will calculate one best numerical based on separating and combined separating and throttling calorimeter. So for combined separating and throttling calorimeter, I will write the equations of combined separating and throttling calorimeter. For combined separating and throttling calorimeter, you have to calculate the dryness fraction value. How will calculate? So with the help of combined separating and throttling calorimeter, value of X is given by X1 into X2, that you know very well. You can watch my video properties of steam 06, in which how that equation comes, after that which type of derivations are there, that you can see. So over here right now, accept the equation X is equals to X1 into X2. So with the help of combined separating and throttling calorimeter, if you want to calculate X, then first of all find out X. How you will find out? Sorry, first of all find out x1. How you will find out x1? So x1 you will find with the help of separating calorimeter. So with the help of separating calorimeter, how you will find out the value of x1, which is equals to ms divided by ms plus mw, where ms is mass of steam, which is given in your numerical, mw is mass of water, which is also given in your numerical. And after that, value of x2 you will calculate with the help of throttling calorimeter. How we will calculate? For that purpose, that you know that H1 is equals to H2 for throttling process. So that throttling calorimeter also you can see in my video number 6, properties of steam 05. Sorry. That H1 is which steam? H1 is wet steam, and that wet steam is converted into a superheated steam. So for wet steam, enthalpy is what? For wet steam, enthalpy is what? HF plus X HFG. So HF plus X2 HFG. Why I am writing X2? Because we are finding X2 with the help of throttling calorimeter. And for H2, superheated steam, enthalpy for superheated steam, that is superheated steam, and enthalpy for superheated steam is what? It is your Hg into Cp of steam, T superheated minus T saturated. So with the help of that, you will get the answer of x2, x1 multiplied with x2, so that you will get the final dryness fraction value. So this much equations are there, which are very much useful to remember. Now we will take one numerical, so that your concept will deliberately clear. So first numerical I will take. So numerical is what? That a sample of wet steam, at a pressure 25 bar absolute. It has dryness fraction of 0.80. So determine the enthalpy and internal energy. So two questions are asked. First question is what? You have to determine the enthalpy. Enthalpy means H you have to find, and internal energy. Internal energy means you have to use this equation, U equals to H minus PV. Now how we'll start this example? So first of all, we have to find out the enthalpy. So over here I will write enthalpy H. So if you want to find out the enthalpy, for that purpose we have three different equations. First one is Hg, second one is this, and third one is that. So first of all, you have to decide among the three equations which equation is applicable for the given example. So it is clear that in the numerical it is said that wet steam. Supposing if wet steam is not given, then also you can say that the given steam is wet. Why? Because dryness fraction is given, which is 0.80, and for wet steam dryness fraction is lying in between 0 and 1. So dryness fraction is 0.80, so 0.80 you can insert over here. That means given steam is wet steam. Now, as you know, given steam is wet steam, so for finding the enthalpy, which equation is useful? That equation. So that equation I will write, which is HF plus X HFG. Okay. Now, if you want to find out the enthalpy, so you have to find out the values of HF and HFG from this steam table, because in this chapter each and every examples you can calculate with the help of steam table, and usage of steam table is necessary. So over here I will prepare one table. In that table, first of all I will write HF. So over here I will write HF in kilojoule per kg. Then next value is which one? Next value is HFG. So I will write HFG. And also you have to find out the internal energy. And internal energy is what? H minus PV. So that V is different for different steams. So specific volume for wet steam is what? X into Vg. That means value of Vg is also necessary to find from this steam table. All these values of HF, HFG and Vg you will find in front of given pressure. And over here pressure is given. Pressure is how much? 25 bar. So over here I will write pressure in terms of bar. In steam table also it is in terms of bar. That HF is in terms of kilojoule per kg, that is also in terms of kilojoule per kg, and specific volume in steam table, it is in terms of meter cube per kg. Now pressure is given, which is how much? 25 bar. So I will write 25 bar over here. Now in front of 25 bar, you have to write each and every values. So I am going to display that steam table on your screen. So from that also you can see the values. So as you can see in front of 25 bar, the value of HF is 961.9. You can write with me also from the steam table that you are able to see on your screen. Now value of HFG is 1839.1 and value of VG is 0.079915. So I hope you have seen each and every values from this steam table. So I am going to remove that steam table. 3, 2, 1. Okay, now come on the board. So value of HF is how much? Value of HF is 961.9 plus value of X dryness fraction is given, which is how much? 0.80, and value of HFG is how much? 1839.1. So that you will get the answer of enthalpy. You can calculate with the help of calculator, which is 2433.18 kilojoule per kg. So that is your first answer. That is answer number 1. That is the enthalpy of this steam which is wet and having 25 bar pressure, having that much dryness fraction. Now we will calculate the internal energy. So over here I will write second question. That is your first question. Second question is what? It is your internal energy. Internal energy means what? U, and U equation is what? U is H minus PV multiplied with 10 raised to 2. That whole equation is not multiplied with 10 raised to 2. That term PV is multiplied with 10 raised to 2 to convert it in kilojoule per kg. Now value of H, that you know, which is 2433.18 minus pressure is given, which is 25 bar. So it is 25 bar in volume for which steam? Volume for wet steam. Volume for wet steam is X into Vg. So instead of V, I will write X into Vg whole into 10 raised to 2. So it will be a 2433.18 minus 25 into value of X is given, which is 0.80. Also value of Vg you have find from the steam table, which is 0.079915 into 10 raised to 2, so that you will get the answer of internal energy, which is 2273.35 kilojoule per kg. So that is your second answer. So that is all about the numerical in which you have to find out the enthalpy and internal energy. I hope you understand, you enjoyed this numerical. Very good. Now next numerical we will take so that your confidence level may increase. So I am going to rub this. You can also pause it and note it down. Next numerical we will take, and that numerical I hope you will try to calculate by yourself. Okay, next numerical is second numerical. Calculate enthalpy for 5 kg of steam at 8 bar under the following conditions. Which conditions are given? First condition is your dry and saturated first condition. Second condition is wet steam. Third condition is wet steam, and with wet steam some data is given. Wet steam having wetness of 40%, and third one is superheated steam at 2 250 degree centigrade. So in this numerical, each and every variety I have taken. So calculate it properly. Now first of all, which thing is asked? Only enthalpy is asked. So first of all, I will write which one? First one, dry and saturated steam. For each and every steam, which thing we have to calculate? We have to calculate enthalpy. For dry saturated steam, we have to calculate enthalpy. For wet steam, we have to calculate enthalpy. For superheated steam, that means over here 3 answers of enthalpy we have to find. Now for dry saturated steam, if you want to find out the enthalpy H, so its equation is what? For dry and saturated steam, enthalpy is what? Only Hg. Over here, dry and saturated steam, for dry and saturated steam, enthalpy is what? Hg. So over here I will write Hg only. So from this steam table you will find out the answer of Hg. Acha. Next also we will take, where I should take? Over here. Next is which one? Next is wet steam having wetness fraction of 40%. So over here I will take wet steam. For wet steam you have to find out the enthalpy. So enthalpy is what? For wet steam, enthalpy is what? It is your HF plus XHFG. Now you have to find out the value of HF and HFG from this steam table, and X is dryness fraction, but over here it is not a dryness fraction, it is wetness fraction. So from wetness fraction, how dryness fraction you can calculate? So you can say like that wetness fraction is 40%, so dryness fraction will be 1 minus 0.4, or you can say 100 minus 40. So if you will write 100 minus 40, so it will be a 60%, and if you will write 100 minus 40, 100 minus 40 is 60%, and in point generally we are considering in decimal term, means 0.8, 0.5, 0.6, because we are writing what? Dryness fraction values lying in between 0 and 1. So it will be your 1 minus 0.4, so it will be your 0.6. So 0.6 is the dryness fraction, and wetness fraction is 0.4, and dryness fraction is 0.6, and our equation is based on dryness fraction. So value of X is 0.6. So from the steam table you will find out the value of HF and HFG and insert value of X as 0.6, so that you will get the final answer of enthalpy. And last one is for superheated steam. Now for superheated steam, enthalpy if you want to calculate, for superheated steam, enthalpy is what? It is Hg plus Cp of steam, T superheated minus T saturated. Now Hg you can find from the steam table, value of Cp that you know it is 2.1 kilojoule per kg Kelvin. Now T superheated, so superheated temperature is given, superheated steam at 250 degree centigrade, so superheated temperature is 250 degree centigrade, minus saturated temperature. Now saturated temperature, how you will find? Simply at a given pressure, 8 bar, in front of given pressure, whatever value of temperature is there, that is known as T saturated. Clear about this? So for that purpose, I will make first of all one table. Over here I will make which values are required. First of all pressure, that is in terms of bar. Then next is which one? Next is Hg. So over here it is your Hg in terms of kilojoule per kg. Next is HF, so I will write HF. Next is HFG, so I will write HFG. Next is your Hg. So I will, Hg so already we have taken from there. Then next is temperature, only temperature. That temperature is known as which temperature? Saturated temperature. Because on the steam table is based on saturated water like this. Then when I will display the steam table on your screen, then you will realize that why temperature in this steam table in front of given pressure is known as T saturated. Now pressure is how much? Pressure is 8 bar. So over here I will write 8. Now from the steam table you will find each and every value. So now I am going to display the steam table on your screen. Now from this steam table you can say that in front of 8 bar pressure, value of Hg is 2767.4. Is it? Yes, it is. Then HF value is 720.9, and value of HFG in front of 8 bar pressure is given as 2046.5, and temperature is 170 0.4. Now in this steam table, on the I think left hand side of your corner of that steam table, I have underlined one thing, that saturated. So that means that steam table is based on saturated things. So that is why in front of 8 bar pressure, whatever temperature that you are able to see, which is 170.4, that temperature is which temperature? Saturated temperature. Okay, now I am going to remove this. Come on the board once again. So each and every value we have. Now simply we will insert the values in all that three equations. So H for dry saturated steam is what? Hg. So Hg is 2767.4 kilojoule per kg. First answer. Now next answer for what? For wet steam, which is HF is how much? HF is 720.9 plus dryness fraction. Wetness fraction is 0.4, so dryness fraction is 0.6 into HFG. HFG is 2046.5. And finally you can calculate the answer for enthalpy for wet steam, which is how much? Which is 1948.8 kilojoule per kg. Now remember this thing, that over here answer you are calculating H is equals to that much kilojoule per kg. That means that enthalpy is for 1 kg of steam. Now actually in our numerical, how much kg of steam is given? 5 kg of steam is given. So that answer you will multiply with 5 kg. Then only you will get the enthalpy for 5 kg of steam. That is the enthalpy for 1 kg of steam. So multiply it with 5 kg. Then only you will get the answer of enthalpy for 5 kg of steam. So what's happened? Kg will get cancelled. So answer will be in kilojoule. So final answer of enthalpy is how much? It is your 13837 kilojoule. So that is your final answer by multiplying it with 5 kg. In the numerical, if 1 kg of steam is given, then that answer is correct. But instead of 1 kg, 2 kg is given. So that answer multiply with 2 kg. So kg will get cancelled. So final answer will be in kilojoule. Similarly over here also, enthalpy you have calculated for wet steam for 1 kg of steam. And actually 5 kg of steam is given. So kg will cancel. Answer will be in kilojoule. So your answer will be 9744 kilojoule only. That is the final answer. And for that superheated steam, value of Hg is how much? Value of Hg is 2767.4. 2767.4. Value of Cp you have to remember for steam. T superheated is 250 and T saturated means in front of 8 bar pressure, temperature is 170.4. So that you will get the answer of enthalpy for 1 kg of steam, which is your 14672.8. That is the enthalpy answer for 1 kg of steam, which is your kilojoule per kg, and that answer you will multiply with 5 so that you will get the final answer. Whatever answer will be there, you can calculate and then you can write. So clear about this example also. In this example, 3 different steams are given and we are calculating the enthalpies for 3 different steams. Now I hope you are enjoying this because maybe you are understanding this. Very good. Now after that, first of all, you just note it down so that I am going to rub it. Now I am going to rub that. Now we will take little bit complicated numerical, and that numerical is also based on the same method. In that all numericals we are considering single point example. Single point example means what? That only single pressure is given. But in this example that I have, 2 pressures are given, that means 2 points are given. Now how to solve that we will see. So numerical number 3 is what? That it is find internal energy of 1 kg of superheated steam at 10 bar and 300 degree centigrade. If this steam is expanded, if the steam is expanded to 1.5 bar and 0.9 dry. Find change in internal energy. Now over here, first of all, we will read the first line, that find the internal energy. Find the internal energy of what? Of 1 kg of superheated steam at this much temperature and that much temperature. Okay, that is your first question. Then you will concentrate on the remaining lines. First question is clear. Find the internal energy of 1 kg of superheated steam at 10 bar and 300 degrees centigrade. So first of all, we will find out the internal energy. And if you want to find out the internal energy, so which equation you will use? You will use this equation. U is equals to H minus PV, in which H is unknown. So first of all, you have to find out H. H for what? Enthalpy for what? Enthalpy for superheated steam. So first of all, we will find out the enthalpy for superheated steam. How will find out the enthalpy for superheated steam? Equation is what? For superheated steam. Over here, superheated steam is mentioned. So superheated steam enthalpy is Hg plus Cp of steam, T superheated minus T saturated. Now, as you know, value of Cp is 2.1 kilojoule per kg Kelvin. Superheated steam and T superheated is also given. Which one? That superheated steam at 10 bar pressure and 300 degrees centigrade temperature. That means given temperature is superheated temperature for superheated steam minus T saturated. Now T saturated, how you will find? Simple. Given pressure is how much? 10 bar. In front of 10 bar pressure, you will find out the temperature. That temperature is for saturated temperature. Clear up to that? Also, you have to find out the internal energy for superheated steam. So that volume is also required. And volume for superheated steam is what? V saturated by T saturated into T superheated. T superheated is given. T saturated you can find from steam table in front of given pressure 10 bar. V saturated is also known as Vg also. Remember that V saturated is also known as Vg. So you have to find out Vg also. So from this steam table, which parameter you will find? So first of all, I will write pressure in terms of bar. So over here, pressure is how much? Pressure is 10 bar. Then next is what? Next is Hg value you will find. Next is temperature. You will find which temperature? That is your saturated temperature, means in front of 10 bar, whatever temperature is that you will write. Then next, which thing you will find? You will find for calculating internal energy, Vg. So that will be your Vg. So now each and every value you will find from this steam table. So I am going to display this steam table on your screen. So in front of 10 bar pressure, that saturated temperature you can see as 179.9. Then Hg you are getting as 2776.2. Then Vg you are getting as V 0.19430. Now that Vg is also known as V saturated also. Now I hope you have seen each and every values. So I am going to remove that. 3, 2, 1. Come on the board. Now over here T saturated value is how much? 179.9. And Hg value is how much? 2776.2. So from that you will get the answer of H in terms of kilojoule per kg. Why? Because 1 kg of steam is given. So value of H is how much? It is your 3028.41 kilojoule per kg. So it is not asked to calculate enthalpy of superheated steam, but which thing is asked? Internal energy. So now we will find out the internal energy. U is equals to what? H minus PV into 10 raised to 2. So which is equals to H minus P into that V. We are finding for what? We are finding for superheated steam. Because given is with steam, superheated steam. And for superheated steam, equation is what? V saturated means Vg. V saturated means Vg. So divided by T saturated, multiply with what? T superheated into 10 raised to 2. Now I will put each and every values. H answer is over here. 3028.41 into V saturated is how much? V saturated means Vg 0.19430 divided by T saturated. Now remember one thing, that over here temperatures are not converted in Kelvin. Why? Because over here difference is there. So if you will write in degree centigrade, then also difference will be same. If you will write this temperatures in Kelvin, then also difference will be same. But over here temperatures are in ratio. So whenever temperatures are in ratio, at that time it is necessary to convert it in Kelvin. Over here also you should convert in Kelvin, but I have not converted. Why? Because if you will convert it in Kelvin or not, answer would be same. And over here you must convert it into Kelvin, otherwise answer would be different. In short, you should remember that in this equation of a superheated steam, all the temperatures are in Kelvin. Okay, so now temperature T saturated is how much? It is your 179.9. So 179.9 plus 273. So 179.9 plus 273. If I will do, so it will be a 452.9. That is your T saturated in Kelvin. 179 plus 273 into T superheated. T superheated is how much? It is given 300, but we have to convert in Kelvin. So 300 plus 273. So 300 plus 273 is 573 into 10 raised to 2. Clear about that? What thing I have done over here? Simply that T saturated, which is in degree centigrade, that I have converted in Kelvin, and T superheated, which is given, that I have converted in Kelvin. So that finally you will get the answer of internal energy as 2782.58 kilojoule per kg. Clear up to that? So that is your first answer. Now we'll focus on the another question. Another question is which one? After onwards we will read the sentence. If this steam is what? Superheated steam is expanded to 1.5 bar pressure. Now that steam is expanded up to 1.5 bar pressure. Now initially what's happened? Initially over here, point number 1, superheated steam is present. That steam is expanded at point number 2. At point number 2, the steam is expanded up to which pressure? 1.5 bar pressure. And over here at point number 1, which pressure is present? 10 bar pressure is present. So over here expansion is taken place, so pressure is decreasing, and as pressure is decreasing, due to the expansion, what's happened? Heat is rejected, and if heat is rejected, so internal energy is decreased, or change in internal energy, du must be in negative sign. Clear about that? What I am saying? One steam is there, that steam is expanded. As it is expanded, so what's happened? Over here, supposing it has high amount of the heat or temperature, and when it is expanded, so its temperature on point number 2 is decreasing. Why it is decreasing? Because heat is rejected, and when heat is rejected, so internal energy is also rejected. That means in a steam, internal energy is decreasing. That is why answer of change in internal energy must be in negative sign. Clear about that? What I am saying? Okay, forget about all that things. If the steam is expanded to 1.5 bar, and next thing is which one? 0.9 dry. 0.9 dry means condition of first steam is superheated steam, and condition of point number 2 is which steam? Wet steam. Why wet steam? Because dryness fraction value is given, which is 0.9, which is present in between 0 and 1. So that is why the point number 2, whatever steam is there, that is your wet steam. Clear about that? Achha. Now 5 bar question, 0.9, find the change in internal energy. Now if you want to find out change in internal energy, so how will find change? Over here, suppose on point number 1, internal energy is U1. That internal energy U1 you have calculated. Now you will find out the internal energy U2 on point number 2. Then only change in internal energy you can write like that. Delta U is equals to U2 minus U1. U1 is with you. U1 is with you. You have to find out U2 by following the same process, but instead of superheated steam, you have to consider wet steam. Why? Because 0.9 dryness fraction is given. So next step is which one? U1 you have, and if you want to find out change in internal energy, so you have to find U2, and U2 means for point number 2. And on point number 2, conditions are wet for 1.5 bar pressure and 0.9 dry. So we will find out U2, and if you want to find out U2, so which thing is necessary? H2 is necessary. That means first of all you will find out the enthalpy for this steam, and enthalpy for that steam how you will find? So over here I will write enthalpy is equals to what? For that steam it is your HF plus X HFG. Now from that H you have to find out the internal energy, and for internal energy V is present, and over here value of V, it is not V saturated by T saturated into T superheated. For this case, it is the case of wet steam, and for the wet steam, value of V will be what? Specific volume X into Vg. So Vg is also necessary to find from this steam table. So over here, I will make one table in which first one is pressure column, then next one is which one? Next one is HF, next one is HFG, and last one is for Vg, and given pressure is how much? 1.5 bar. Over here 1.5 bar is given, or I have done some mistake. Okay, 1.5 bar. Pressure is 1.5 bar. Now in front of 1.5 bar you can see the values from the steam table, so I am going to display the steam table on your screen. So in front of 1.5 bar, that the value of HF is 467.1. you can see HFG is 6.3, and value of Vg in front of 1.5 bar pressure is 1.1590. Now I hope you have seen this value. Now come on the board, I am going to remove that. So that values we will insert over here. So H is equals to how much? HF is what? 467.1 plus value of X is given, which is 0.9, right? And value of HFG is 226.3. That's it. So value of H you will get. Value of H is for wet steam 2470.77 kilojoule per kg. Now that is the answer of H, but it is not asked to calculate. Why we are calculating? Because we want to find which thing? We want to find internal energy, which is at point number 2, H2, U2. And U2 is what? H. Which H? Now this H. H2 you can say. Over here you can say H1 also. As per your convenience, you can select the symbols. So internal energy U2 is what? H minus PV into 10 raised to 2. So U2 is equals to H. H so you have calculated, which is 2470.77 minus pressure is given. Pressure is 1.5 bar into X into Vg into 10 raised to 2. Why I am writing instead of V X into Vg? Because we are talking about which steam? Wet steam. And for wet steam, specific volume is X into Vg. So U2 is equals to how much? 247077 minus 1.5 into that X is 0.9 into Vg is how much? Vg is 1.1590 into 10 raised to 2. So value of U2 you will get in kilojoule per kg. So value of U2 internal energy at point number 2 is 2470.77. Now you have U1, you have U2. Now you can find out the change in internal energy, which is asked change in internal energy. How you find? So delta U change in internal energy is 24770.77 minus U1. U1 is how much? 2782.58. So the delta U answer you will get, and delta U answer will be what? It is your minus 311.81 kilojoule per kg. Over here your change in internal energy having negative sign. Why negative sign? Because that steam is expanded. So what's happened? Internal energy is decreasing and heat is rejected. So that is little bit complicated example. I hope you have enjoyed. You can understand this. Okay, very good. Now we will take the last numericals. First of all, note it down quickly. Then we will take the last numericals, which is based on combined separating and throttling calorimeter, and then I will end this video. Okay, I hope you have noted down. I am going to rub that. So now next numerical is based on calorimeter, and generally combined calorimeter numericals are asked, not the individual calorimeters like separating, throttling, separating calorimeter, barrel calorimeter, and all that things. Combined calorimeters are asked. Okay. Now we'll take one numerical based on combined calorimeter. So numerical will be like this. I think numerical number 4. Combined separating and throttling. Calorimeter has following data. Some data are given. First data is which one? Main pressure is equals to 12 bar absolute. Next is mass of water collected in separating calorimeter is equals to how much? Mass of water is 2 kg. The next is mass of steam. Mass of steam condensed. Mass of steam condensed in throttling calorimeter is how much? It is 20 kg. Next is pressure after throttling process is equals to 1 bar. And next is temperature after throttling process is equals to 110 degree centigrade is equals to 110 degree centigrade. And Cp of steam is given, which is 2.1 kilojoule per kg Kelvin. And question is what? Find the dryness fraction. Find the dryness fraction of steam. That is the question. So that is the numerical based on the combined separating and throttling calorimeter. That would be the last numerical. Now how will solve this? So first of all, you have to find out the dryness fraction value of this steam with the help of which calorimeter? Combined separating and throttling calorimeter. So how will find out the dryness fraction value of this steam with the help of combined separating and throttling calorimeter? So over here, with the help of combined separating and throttling calorimeter, if you want to find out the dryness fraction value, so it will be your x is equals to x1 into x2. So over here I will write x is equals to x1 into x2. So first of all, you will find out x1. So over here I will draw one line. So I will find x1 with the help of which thing? X1 with the help of separating calorimeter. So x1 with the help of separating calorimeter. Then next I will find x2 with the help of what? x2 with the help of throttling calorimeter. Now if I want to find out x1 with the help of separating calorimeter, so equation is what? X1 is equals to what? Ms divided by Ms plus Mw, mass of steam and mass of water. So x1 is equals to mass of steam is given, mass of water collected in separating calorimeter is 2 kg. That means mass of water is 2 kg and mass of steam is 20 kg. So mass of steam is 20 kg. 20 divided by 20 plus 2. So value of x1 you will get as 0.9090. Now remember one thing, whenever you are solving the numericals based on the combined calorimeters, at that time value of x1 and x2 you have to keep up to 4 decimal. Up to 4 decimal means what? Over here 0.1234 4 decimal. Then only when you will multiply both, then only you will get the correct answer. So in short, you should remember that you have to put the answer up to 4 decimal. Okay, that x1 we have easily calculated. Now we'll go for x2. Now if you want to find out the value of x2, so how will find out the value of x2 with the help of throttling calorimeter? That you will write the equation enthalpy before throttling process is exactly equals to enthalpy after throttling process. Now at the inlet of throttling process, wet steam will enter, and at the outlet of throttling process, that steam is converted into a superheated steam. That you know very well if you have seen the derivation. Now for wet steam enthalpy is what? For wet steam enthalpy is what? It is your HF plus X2. HFG, that you know, HF plus X2 HFG, and which is equals to, for superheated steam, enthalpy is what? Superheated steam, it is your Hg plus Cp of steam, T superheated minus T saturated. Clear to that? Now we will find out the values, but before that, H1 means what? Enthalpy before throttling process, and HF and HFG value if you want to find. So on which pressure you will find? Whatever pressure is there before throttling process, or whatever main pressure is there, that is your main pressure, and then throttling process is taken place, and then pressure is changed. So whatever main pressure is there, that is known as pressure before throttling process. So in the numerical, main pressure is given, that means that is a pressure before throttling process. Before the throttling process, pressure is given. So before throttling process, pressure is 12 bar. So over here I will write 12 bar. That means in front of 12 bar, you will see these values. Clear about this? And H2 means for this term, H2 means what? Enthalpy after throttling process, and Hg and T saturated you can see at which pressure? Pressure after throttling process. So over here, pressure after throttling process is 1 bar. So over here I will write pressure after throttling process is 1 bar, and also that temperature after throttling process is 11 degree centigrade. That means superheated temperature is given, which is 11 degree centigrade. Clear about that? What I am saying actually. And so now over here we will prepare the table. So how we will prepare? First of all, we will find the values of what? Values of HF. Then next is HFG, that's it. Okay, then pressure is how much? 12 bar. Then for this case, for H2, for this case we will find out what? We will find out first of all Hg. Then we will find out T saturated. So T in front of given pressure is how much? 1 bar. Whatever values are there of temperature, with that we will consider as T saturated. Clear about that? What I am saying? In front of 12 bar pressure, in front of 12 bar pressure, in front of 12 bar pressure, all these terms value we will find from this steam table. And in front of 1 bar pressure, each and every value of that term we will find. Clear about this? Achha. Now I am going to display the steam table on your screen. So from the steam table you can write the values of HF in front of 12 bar. Pressure is how much? It is 798.4. 798.4. Concentrate properly. 798.4. Then in front of 12 bar pressure, HFG is 1984.3. Now next is your in front of 1 bar pressure. So in front of 1 bar pressure, I hope that 12 bar and 1 bar both are in a single sheet. If it is not, then I will display another steam table on your screen. So in front of 1 bar pressure, saturated temperature means in front of pressure temperature is 99.63, and value of Hg is in front of 1 bar is 2675.4. Now I hope you have seen the values. Now I am going to remove it. 3, 2, 1. Now come on the board. Now we will put each and every values over here. First of all, HF. HF means this in front of 12 bar. In front of 12 bar. HF is how much? It is your 798.4. Then plus X2 you have to calculate. Then HFG. HFG in front of 12 bar. In front of 12 bar. HFG is how much? It is your 1984.3. Which is equals to what? Which is equals to this values in front of 1 bar. In front of 1 bar, which thing? Hg. Hg is what? 2675.4. Then plus Cp of steam is 2.1, which is given also in your numerical 2.1. Then T superheated is also given, which is 110 degree centigrade. You can convert it in Kelvin also, but answer would be same, as it is a difference, not the ratio. And T saturated is how much? It is 99.63. So you will make X2 as the equation representative. So X2 will be what? 2675.4 plus 2.1, 110 minus 99.63. Now that term will go over here. So minus 798.4 divided by this term 1984.3. I hope you can read this bottom values. So value of X2 you will get as up to 4 decimal. It is 0.9569. So x1 and x2's values are there with you. Now simply what you will do, that both of the value you will insert over here. So x1 is how much? 0.9090, and x2 is what? x2 is 0.9569. So finally you will get the answer. Now you can write up to 2 decimal, which is 0.87. So now that is the mathematical procedure to calculate the dryness fraction value with the help of combined separating and throttling calorimeter. Now I would like to end this video. Again I am saying that if you will solve the numerical by yourself, then only you can build up your confidence level. So till then, read hard, work hard. Thank you very much.